Okay, in this video I'm going to show you how to generate the PWM waveform using the STM32 Nucleo board. So first I'm going to open the STM32QMX. Go access the board. We are using the Nucleo 64 and the IC is L053R8. Double click on this and initialize all peripherals with their default. On the board, the high-speed crystal is not connected, so we can put these two pins into reset state. So for PWM, it's come under the timer. So let's say we use the timer 2. Before we set the PWM, we have to initialize the clock. So we use 32 megahertz. And in the timer 2, we set the clock source from the internal, and we're gonna use PWM generation channel 1. Automatically this pin is set to timer 2 channel 1 PWM mode, and we will be setting the settings for the PWM, but before that we have to do some calculation. So right now the clock is 32 megahertz. Okay, we set the requirements of the PWM should be 40 kilohertz with 50% duty cycle. First, we can do a prescaler of say 8. So the output clock will be equals to 32 megahertz divided by 8. We will get 4 megahertz. Why we use 4 megahertz is because it's for our convenience. 4 megahertz is 100 times faster than 40 kilohertz. So which means that for the upper pulse of 4 megahertz, if we count the pulse for 100 times, we'll get the period of the PWM of 40 kilohertz if we count 100 times, because it's 100 times faster than more pulses than the 40 kilohertz. For 50% duty cycle, we have half the number of counts for the pulse. Okay, so for this, the pulse will be, we need 500 counts. We will need 50 counts to generate the 50% of the pulse. So this refers to the pulse, and the count refers to the period, and the prescaler was set to 8. So we have to set these 3 parameters. So for the prescaler, we set to 8. According to the datasheet, you have to set 8 minus 1 according to the equation, because it's counting from the 0 onwards. So and the period, it's for the period count, we'll count 100 times. So it's similar, 100 minus 1. Okay, so no division. The rest we put in the default except for the pulse. So pulse, this is the number of pulses to get the 50% duty cycle. So half of the period count is 50. This is 50, no need to put minus 1. Okay, and that's all. So we generate the project, we put a name PWM example. We're going to use the Cal Microvision, so it's MTK ARM, and we generate. Open project. So we're going to the application. The only thing that we need to do in the source code is to start the PWM. So we put it before the while loop inside the user begin to. So it's how timer PWM start, and we are using the timer 2 and channel this is channel 2. Okay, if we are not too sure, we can look into the initialization. Timer 2 initialization will tell you the channel that we're using. So it's the timer channel 1. Back to here, back to PW start. So this will be timer channel 1. Yes, we compile. Okay, I forgot that, so we need to set the option under debugger preset. Compile one more time, make sure there's no error, and we go into the debug. We don't need this window, and okay, I have to set up my oscilloscope. Okay, once I run, I should see 50% duty cycle. Okay, I'm not sure whether I can see clearly. Let me zoom in. Okay, so here it says 40 kilohertz. Okay, and the duty cycle is about 49 to 50%. Okay, so let's say we want to change the duty cycle to 10%. Okay, to change to 10%, we can go in, or we can either go into the QMX to change the pulse to 10, or we can go into timer initialization, MX timer 2 init, and change the value of 50 to 10. Okay, we are exit the debug, compile, make sure there's no error. Okay, and go into the debug. Okay, and run. So you can see the duty cycle has changed to 10%, and the frequency remains at 40%. Okay, so that's it for this video.